This is your first statistics lecture for the class. Now there's going to be a sequence of these lectures as we go through. So it's going to be important that on each individual one, you completely understand the content and the concepts before you move on to the next. Ideally, this will be easy because these lectures, at least the first couple, were originally created for the freshmen to get a basic understanding of statistics. Now we're going to be going beyond them, but at least for these first 3 or 4, they were already made for the freshmen. Now, on the other side of that, that means that they're going to move pretty slowly and they're going to be very redundant, and I'm going to say things multiple times over. So hopefully that doesn't frustrate you, and instead it actually helps solidify the information a little better. So remember, just pay attention to each one of these lectures very carefully, because the next one builds on the information from the last. This entire lecture is on understanding averages and what an average is. Now, what is an average? That's our big question that we're trying to answer in this lecture. So take a moment, pause the video, and answer the question, what is an average? Okay, so most of you probably said that an average is when you add everything together and divide by the total number of things. Whereas that's true, that is absolutely true, it is not the question that was asked. The question is, what is an average? Not how do you calculate it? So conceptually, the question is conceptually, what is an average? Can you answer that? What is the definition of an average? Not what's the math formula to calculate it. So this is what we're going to dive deeply into during the lecture, which you probably never seen before. Now, first is some terminology. In professional statistics, we don't use the word average. We use the word mean. I don't really know why, but we use the word mean instead of average. But they are totally equivalent, 100% the same thing. So I think maybe it's because you've got median, mode, and then to keep it as another M word, it's mean. Now, the symbol, the mathematical symbol we often use to represent the mean of a set of data is mu. That's this nifty little symbol here on the side that looks kind of like a U, but it's not. It's a Greek symbol, mu. Now, the way you write this symbol, if you want to know, is you start on the bottom left and you go up and then back down and then swoop up again and come back down, just like that. So that's the way you write that symbol for an average, for a mean. To get to the heart of what an average is, we're going to look at it through an example. So here on the screen right now, I have a data set X. So we're going to call this data set X. And it's got 6 data elements in it, 4, 2, 13, 7, 16, and 6. And what you see here is that each element, right, X1, X2, X3, is given this subscript, 1, 2, 3. All that says is, of the data set X, we're talking about element 1, which in this case is 4. X2, or the second element, is 2, and the third element is 13, and so on and so forth. So this is going to become important later when we look to see how we actually write this in statistics notation. Right? But for now, let's plot our 6 numbers on a number line. So first let's start with our lowest and highest number, 2 and 16. Let's let them bounce in here. 16 and 2. Let's put our next 2 down, 13 and 4. And then finally 6 and 7. So those are all the numbers we have in our data set on the number line. And the next step is to calculate the average. So the mean, mu, is going to be 4 plus 2 plus 13 plus 7 plus 16 plus 6 divided by the total number, which is 6. So again, add everything together and divide by the number of things you have. And that gives us a mean of 8. So let's plot that on the number line also. Let's toss down our 8. There's our mean. All right, so now, to press forward, we have to learn a new word, or what I think is probably going to be a new word for most of you. And that's deviation. So the dictionary says that deviation is the action of departing from an established course or accepted standard. An example is a deviation from a norm. So whenever you veer off course, whenever you don't stay straight on a particular path, you are deviating from that path. That's the verb. in statistics, we say deviation from the mean. So what that means is anytime your data set deviates from the average, deviates from the number 8 in this case, that is a deviation from the mean. And we measure how much that deviation is. How much does 4 deviate from 8? How much does 13 deviate from 8 in this case? So we calculate each one of those deviations. So it's fairly simple. We're just using special words for it now. But here, you'll see that the distance from 8 to 4, that's the deviation, is negative 4. 4 is minus 4 below 8. That's the deviation. So from 8 to 4 is negative 4. And we do this for each number. So the deviation of x2 from our mean is negative 6 because the value is 2. And now the opposite way, if the number is larger, the deviation is 5. So between 8 and 13, you get 5. And then the next, between 7 and 8, is negative 1. And between 8 and 16, the distance between them is 8. And then finally, the distance between 8 and 6 is negative 2. All right, so those are all of our individual deviations. And you see that they've updated in the table at the top too to show the deviations for each one. The next step is to add all of our positives and all of our negatives together. So let's add our positive deviations together, 5 and 8. If you add 5 and 8, you get 13. Now, what if we add all of our negative deviations together? What are we going to get? Well, we get negative 13. Look at that. They are the same but opposite numbers, 13 and negative 13. So now, if we add our positive and negatives together, we get 0. That is always the case. This is actually what the definition of an average is. If you add all of those deviations from the mean together, you get 0. That is the definition of an average, is when you add all those deviations, the total should always be 0. Isn't that really, really cool? I think it's really, really cool. Well, I don't even like you, boredom baby, so it is cool. Who cares? It is awesome, it is very cool, and you should know it and be excited about the fact that when you deviate all numbers, they come to 0. So this is the definition of an average. An average, or a mean, is a number such that the sum of all deviations from that number equals 0. So again, I'll read it again. A number such that the sum of all deviations from that number equals 0. So that's just doing what we did before. When you add up all of those differences from the mean to each element and then you sum them together, you get 0. Next, we need to learn some new mathematical terms. Now, we learned a couple of operators so far. The delta operator, we looked at vectors, we looked at trig functions. So here's our next operator, and it's the Greek letter sigma. And here's the full example. So we're going to walk through what each one of these pieces means here. So the sigma itself means add stuff together. It means add a whole bunch of stuff together. And the stuff you're adding together is the equation. So what this says is the summation symbol says add n plus n plus n plus n plus n dot 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 as many times as you need. N plus n plus n plus n, because that's the equation. Now, the difference here and what makes the summation symbol very important is that n is not always the same number. N keeps increasing by 1 each time. So this down here, the variable you put down here tells you what number or which letter, which symbol in your equation you're going to increase by 1 each time. This value tells you which number to start at, what's their lowest value to start from, and this tells you when to stop. When should you stop incrementing? So what this symbol actually says is take add n 6 times, but increase it by 1 each time, starting with 1. So let's take a look. So it's going to be, you're going to take n plus n plus n plus n plus n, 1, 2, 3, 4, 5, plus n. Except each time, we're going to start at 1 and increase by 1. So the first n is going to be 1 plus, then we add 1, 2, plus 3, plus 4, plus 5, plus 6. And that gives us a grand total of 21. And that's it. So the answer to this equation is 21 if you do that out. So you take the equation and you just iterate, the word is iterate or increment, by 1 each time from the lowest number to the highest number. So we're going to look at a whole bunch of examples here just to try to solidify this idea so you get a feel for how it works. Here is our next example that we're going to look at for how to use the summation operator. So we're going to have the sum of 2n from 3 to 7. That's how we say it. The sum of 2n incremented from 3 to 7 is the way you would say that. So this is going to equal, if we write this out, so we start with our lowest number, which is 3, and we put that into our equation here. So that's going to be 2 times 3 plus, and now we increment, and so 3 goes to 4. So it's going to be 2 times 4, and then we increment again, plus 2 times 5, and we increment again, plus 2 times 6, and one last time because we end at 7. That's where we're supposed to end at. So we're going to have 2 times 7. So we look at each one. This is going to be 6, 8, 10, 12, and 14. And then we add all of those together. And that gives us a grand total of 50, right on the mark. So that's the answer to this equation. So we just add them up. The next one we're going to look at is here. Now, instead of multiplying, we're squaring. So our equation is n squared. So it is the sum of n squared incremented from 2 to 5. That's how we would say this. So this is going to equal, again, we start with our lowest number, 2. We put that into the equation. So we're going to have 2 squared plus, now we increment 1, 3 squared, increment again, 4 squared, plus, and then finally we end at 5. So we do 5 squared. And this is going to be the same. So we're going to simplify. So that's 4 plus 9 plus 16 plus 25. And that gives us 54. 54 is the answer to this equation. Now the next example is going to be the summation of n minus 1 incremented from 1 to 4. Now this one is actually pretty simple overall. So we're going to start with 1 and put that in for n. So that's going to give us 1 minus 1 plus, now we increment, 2 minus 1 plus 3 minus 1. And then finally, for our last one, because we end at 4 again, we're going to have 4 minus 1. And now in each case, you're just subtracting 1. So it's going to be 0 plus 1 plus 2 plus 3. And that answer is 6. Okay, so those are the first 3 examples, but I want to do let's finish out this by looking at 3 final examples. Here's our first one. The summation of n minus 1 squared incremented from 1 to 5. So here, we're going to have, again, we start with 1, and we put 1 in for n, minus 1 squared, which we know that's just going to be 0, plus, now we increment 2 minus 1 squared, plus 3 minus 1 squared, plus 4 minus 1 squared, plus, finally, 5 minus 1 squared. And so for each case, this is going to be, so this is going to be 0, it's going to be 1, this will be 4, this will be 9, and this will be 16 if we calculate those out. And so the sum total of all of this is going to be 30. All right, there's that example. Now, we're going to change things up a little bit. And in all of these examples so far, we've directly used n as its value. We replaced n in the equation, and we used that number 1, 2, 3, 4 to actually find the answer. But n doesn't have to be directly in the equation. It can also be a reference. And what I mean by reference is, if you remember this table from before, this is our same data table from the example, we have these small indicators here. We have these element indicators, x1, x2, x3, x4, etc., etc. We can put n in for these. So instead of having x be 1, 2, 3, 4, we just have this reference indicator down at the bottom that says, okay, x1, oh, that's 4. Oh, x2, that's 2. x3, that's 13. So the way we would write that then, for this case, because we have 6 data points, would look like this. So we would have the summation of xn incremented from 1 to 6. So this would equal x1 plus x2 plus x3 plus x4 plus x5 and then plus x6, which these values are given in the table. So they would be 4 plus 2 plus 13 plus 7 plus 16 plus 6. And if I add all of those together, I get 48. So this is a way to use n not directly in the equation, but as a reference instead, a reference to a table of numbers. And this is very common when you're looking at statistical data. Finally, the very last example we're going to look at here is this one. So now remember, mu is your average. And from our data set, our average was 8. So this is saying take each data point, take x1, x2, x3, x4, x5, x6, and subtract that from the mean. And what are we going to get if we do this equation? So xn minus mu incremented from 1 to 6. What are we going to get if we do that? So let's write this all out here. So we're going to get 4 minus 8 plus 2 minus 8 plus 13 minus 8 plus 7 minus 8 plus 16 minus 8, and then finally plus 6 minus 8. And let's look at each one. So this is going to give us negative 4. So it'll give us negative 6. So it'll give us 5, negative 1, 8, and negative 2. And if we add all of these together, we get a grand total of 0, as we should, because this, if you haven't realized it already, is our deviation from the mean. That's what this is. Take your data point and subtract it from the mean. That's by definition our deviation from the mean. So this is how we write it in professional statistical terms. We would write it like this. So this answer should always be 0 for whatever your data set is. Finally, I want to go back to something that I think you said near the beginning of the lecture, which is that an average is when you add everything together and divide by the total. So this is correct. This is how you calculate an average. But how do we get to that formula from this idea that the sum of all the deviations must be 0? To do that, let's look at our general example. And by general, I mean that we're not going to specify exactly how many data points or data elements we have. We're just going to say that the total number of data points we have is the capital letter N. This could be 6, it could be 50, it could be 100, it could be 9,000. Doesn't matter. It's just the total number of data points. And if we use that, then we're going to get this generalized formula for the definition of an average. So this is the definition of an average because the definition is that when you sum all of the deviations from the mean, so here's our deviations. When you sum all of the deviations from the mean of all of your data elements, you must, by definition, get 0. This is how we define the average. So now, how do we get to that formula, add it all together, and divide by the total? So first we have to expand this out a little bit, which means let's just take the first couple. So we're going to have x1 minus mu plus x2 minus mu plus x3 minus mu dot 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 all the way out to xn, capital N, minus mu. So now, this is just addition and subtraction, so we don't need the parentheses in this case because there's no multiplication or division. So we can drop those and we're just going to have x1 minus mu plus x2 minus mu plus x3 minus mu dot 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 all the way out to xn minus mu. And now we can rearrange this equation to put all of the mu's together and all of the x's together. So now I'm going to put some parentheses back in, but we're going to make it negative mu minus mu dot 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 out to however minus mu's we need based on how many n's. Plus, now x1 plus x2 plus x3 plus dot 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 all the way out to xn. Just like that. All right, so now what you're going to notice is I can actually combine all of these mu's. If I just count up how many negative mu's I have, I can simplify this down and I don't have to keep doing minus, minus, minus. Okay, so this is going to give us negative n mu for the first one, because we're actually going to have n mu's because we have n data elements. And then we're going to have plus. Now this is just a summation again. This is the xn, so this is going to be the sum of n equal 1 to n of xn, like that. So this is our new equation. And now this equation here, again, still equals 0. And if we rearrange our equation now, so let's add this negative n mu to both sides. So that's going to move it over to the 0 side. And we're going to get positive n mu equals the sum of n minus 1 to n, or n equals 1 to n of xn. All right, we're almost there. So the last step we have to do then is if we divide by our capital N now, our total number in the system, then we're going to get our final equation, which is going to be mu, our average, which is what we were looking for, equals the sum of n equal 1 to n of xn, all divided by n. And this is our definition, or this is our calculation for an average. So there we go. Mu equals the sum of everything together. You add everything together, and then you divide by the total number of things you have. That's how you get to that equation from this idea of deviation. So again, super cool. This whole idea of deviations comes together and is super awesome. Not you again. Boredom Baby is never happy with anything. Well, it is cool, and you should think it's cool too. Okay, but we're done for the day. That's the whole lecture. All right, have a good night.
That's all, folks.